This episode of Fenugreek Machining is going to be about two couples of cylinder heads and their studs. 8 of them to be exact. Well, let's see. This is what you are about to experience today. So it's a piece of rectangular piece of steel which we then will make a Swiss cheese. So there will be one big hole in the center and then one slanted side. It's 22.5 degrees. And then there will be 9mm fine thread. Oh well, and then 4 holes poked all the way through. Well, I guess that's about it. Oh yeah, a small hole here in between. So this is one of those. So we start in the mill, make 2 couples of pieces like this. And the material I'm going to use is this, which you probably recognize from the earlier project. It is, it was scrap, now it's raw material. So, and then we will make 8 couples of studs like this. Very simple. Well, I don't have the 5mm stock, so I need to make it from, well, I have 10mm is really abundant, so I will use that. I tried already, so you can actually make it quite neat. This is just a try how it goes in the lathe. It goes well. Okay, so and that's too short. So let's start with milling this one to the correct size. I almost ruined this material. Well, if you can see this here, well, I was supposed to take 0.1mm of this one. Well, this is now exactly 0.9mm below the surface. Yeah. Oh yeah. For some reason I thought, okay, 1mm more, it should have been 0.1. So now, luckily, I looked at it again and, oh, that doesn't look like 0.1mm. No, it does not. And, well, we have barely enough material for this one. So, next step, I will clean the mess I have made. It's quite a lot of that. And after that, I will use this slitting saw to take 2 30mm parts of this piece. And yeah, why slitting saw? Why not hacksaw? Because it takes care of the finished surface in one go. So that's the reason why slitting saw, and I have that. So that's another reason. So now. One of the things you should really do, and when you do it properly. Clean up. the slitting saw was both a bad and a good idea. It was a good idea, but I chose the wrong type of slitting saw. So therefore it was really musical. Okay, and I managed to get a very bad surface finish, some parts here. Okay, but now everything is all right. And this one is actually, I already did something here. I made this Swiss cheese thing here. So, and now there is a change of plan. Namely, it won't be two identical pieces. It will be one for cold side and one for hot side. The hot side will be different in a way that there will be two holes in this side all the way. The center hole will be all the way through to the cylinder, and then we will have another one which is not the whole way through, but well, it is like here, so that I can put a copper loop of copper tube here, and this is of course to collect the warmth and well, yeah, heat collector, so to say. And the cold side is as stated here. So now what I will be doing is the hot side. So therefore I already did this. So therefore my some of the settings are there already in place, but we need to do some dialing there for the x-axis, and yeah, and then we just drill a few holes. Put this piece into the vise somewhere here, yeah, and I have already cleaned up this quite well, so there won't be any chips on the way. So now it is there somewhat, but it's not tight enough. So, as always, a little bit hammering, very gently. I don't want to yeah, you can hear it's not all the way in. This was not successful. Now it is. You can also, okay, well, this lifts the jaw, I believe. Okay, well, this should be anyway taken off. Well, it is now there. It's good for our holes. Anyway, set this one to our reference side. So, well, I have purchased a new tool. Yeah, this one. And we need a little bit speed with this one. It won't work with low speed. And we'll do a little bit up, I believe. Let's see now. We don't need to adjust the Y because it's already adjusted. And now I'll just well, yeah, let's see. Our zero is not zero, it's 3 millimeters that way. Now it's on zero. And these are all the way through. All the way through. There you go. And 5 millimeters was the place. Okay, there you are. And lock that. And then this one also 5 millimeters. Okay, now this is ready. This part of the job. Next thing I will again clean a little bit because I need to change the vise here. This is not a good vise what we are doing next here. So I have another type of vise for that. Well, setting up the angle to be able to mill this tilted surface on these ones. And this is a vise that I purchased quite a long ago mainly for manual jobs, but it has proven to be quite good for this one. Okay, so this one is my Hahn & Kolb Stuttgart protractor. I have set this up to, have I? No, I have not. It's 11.5, it should be 12.5 degrees. Now it is. So, no, and not 12, it should be 22.5 degrees. So 22.5. Huh. Oh yeah. Hopefully this is okay. Okay, maybe I can. I have to. Oh yeah, okay. So now I will adjust this vise to be on that. Okay, I can do this. So I feel these. If the edges here, this is a little bit awkward. No, it's quite near. Now it's over. There you are. It's not like second precision, but it suffices for this job. And now I tighten this, and now we should be in the correct 22.5 degrees angle here. So it should be half of 45 degrees. And now putting these into the vise, it's really important that you put them in the correct way. So this is top side and it should be tilted this way. So if I put it that way, it will be, the end result will be wrong. This way, right. And also there are some things like it really doesn't matter in which orientation this is, because this is not 13 millimeters, it will be 14. Why in earth do they put different fasteners here? Yeah, it is 14. So the this orientation doesn't really matter. This is because all that matters is that it is plane in horizontal orientation. So I will put it somewhere like here. There you are. And now tighten the vise. Well, there you are. First piece is there, and now hopefully I need to recheck this one. So it's lower this side and this is the underside. Yeah, that's correct. And this is actually the cold side cylinder head. So okay. So next step, mill it down. Okay, so this is the one where we are going to need a loop here, and well, it should be made out of copper for good thermal conductivity, and and it's a quite tight loop actually. They are quite near each other. It's 8 mm in diameter, and I have the proper material for this one. Okay. Well, you could just do like this and bend it. Well, it would not work. There is a good reason for that. It would deform in the middle and probably would block the passage of air inside there. Not a very good idea. And now, this is where what we are going to do now is to fill this tube with, not with steel wool, but with water. I have now pre-soldered this and that end, and the whole tube became really warm. And now I will flatten this one. So it is quite flat. Yeah. And then I will clean up it a little bit from here. Because now what I'm going to do next, I will solder it again. Okay, now it is soldered. Next step around here will be to fill the tube with water. So now this one is completely filled with water, and I tried to make absolutely sure there are no air bubbles inside there. And the next step will be to squeeze it at the end first. Let's do this in the vise. I'll take this off. So I will squeeze it from here. I try to make this so that none of the water escapes from there. Starting from here. I'm still trying to avoid this one. Now, this is the moment of truth. I did some soldering here. This was really awful. It tried to boil, so I needed a lot more of this, and after that I was able to solder it without it blowing all the solder away. Now it should be air, and it should be tight. So now this is just my setup. Well, now let's see. Really, moment of truth. Oh, let's see. This is awful. I'm a little bit scared of this. What happens here? Well, it definitely does not work. Now, that wasn't very successful. The next method will be to use, water, but this time we will the end bend it, that, yeah. And now I go and fill this with water. Now it's filled with water, and I will squeeze the end. Okay. What I'm going to do now is to freeze the water. Now here is our second moment of truth. It has been sitting in the deep freeze the whole day, and what has happened is that I put the glass to isolate, not to warm it up. So it has swollen on the other end, as you can see. Okay, now let's see if I can bend this better now. Moment of truth, really. Oh yeah. It didn't go well as I would expect. A little. This is now my third option to make that very tight bend. Actually, the tube edges would be only 2 millimeters apart from each other, and that kind of bend is next to impossible to make into a copper type of this thickness. It's 8 millimeter outside and only 1 millimeter wall thickness, so yeah. So what I will do, I will cheat. So first of all I will put this drill bit inside there. This is a 6 millimeter drill. In order, let's see, yeah, I'm not in danger of filing my drill. So in order not to squeeze the tube, this tube cannot be attached into the vise without squeezing it unless you have something like that inside. Okay, next thing, I will file for 45 degree slots there. I will start with this triangle shaped file because it is goes faster. So let's do this. Okay, now I change to this. Well, it's a 5. And let's see. Okay, I have made it so that there is a dark band which should be left alone. Now let's see. Oh yeah. Okay, and now this one. That gap might become a little bit too wide. Yeah, there you are. Done that far. And now this is really easy to bend, but I don't want to bend it just yet. let's see if I can get the drill out. Yeah, it didn't crush it too much. This needs to be taken away carefully, not to disturb. Okay, got it out. And no drill bits were harmed during this video. Okay, so first of all I have cleaned this up, deburred it and whatever. So what I need to do is to put some flux into there. And this is, well, just flux. And the rule of thumb is that you put flux only where you want to have the silver solder. Well, you don't need a lot of this, just some. And now, bending. Let's see how this goes. That was bend number 1, bend number 2. Well, it looks, well, it looks like it looks. Well, how would I do this? Ah, now I know. I will put it this way. Okay. But then I need to turn this way. Otherwise I will end up in some mess at some point when it drops off. Of course it will drop off on me. Okay, there you are. Now just warm it up. So first, just gently here, just to evaporate the, yeah. I have here some extra flux. If I ever need it, I will put something into my stick. Did it go there? Okay, now it does. So, and this will happen probably very quickly. Note that I'm not heating it from here. Okay, now it looks like we are going to... That's probably more than enough. Yeah. Let's see how that comes out. Well, it was amazingly easy. Copper seems to be a good material for not brazing, this is silver soldering. So, oh yeah, and it starts to drop off. Well, we need to wait until it cools down and then see what kind of surprise is waiting on the underside. Aha! You can see this. This is perfect. This is perfect. First of all, I cleaned up the ends of these tubes really well. Decreased this piece really well, and then I have put some flux in there and then placed some bits of silver solder around there. There is a quite big chamfer which I'm now hoping to get filled by silver solder, and then by capillary action it should go into the joint as well. So let's see what happens here now. This might backfire on me. And yes, Okay, let's see. First, a gentle warm-up to get rid of the water. In the flux, it's water-based, so there is water as diluent. Yeah. And well, looks like we are quite soon there. Yep. Okay. And I will warm this from the underside because the silver solder follows the heat. Oh, beautifully. Hopefully it does the other side as beautifully as well. Oh yeah, now it's melting, melting. Okay, let's take some heat to the copper, but it conducts the heat into the cap. Yes, it does, and it did well. Good. I think we are there. Now I tried to remove the flux residue from this one, but it seems to be really hard to remove. Okay, anyway, now it's reasonably clean, and the copper tube looks as if it should be warmed. Okay, and I haven't tested it yet, but I'm quite confident this is airtight. And yeah, and the other one, the cold side cylinder head, it's what it is. I deviated from the original plan. We should have had here M9 fine thread, but I decided that okay, I will make a flange here, so the orientation becomes correct every time. Well, I did promise that we are going to make the studs to attach these to the cylinders and the base, but nah, they are just simple lathe work. Just make a 5mm thing and then thread it on the ends with a die. So that's it. Okay. And furthermore, in the next episode of Finno Machining, we are not going to do anything for this Stirshurst engine. Instead, we are going to look inside this box. Till then, bye!